Good afternoon, participants. So we will start our second session of the day. It is the sixth session overall. So the resource person is Dr. Sayyid Abdul Basith. He has completed his PhD from IIT Vellore and then he's pursuing his PDF in IIT Madras. He has two uh, papers published in high impact 20 impact factor journals, and he also have many patents in his name. I'm sure his session will be worthwhile, and without much formal introduction, I'll welcome Dr. Said Abdul Basit to the session. Welcome, sir.
Yes, sir. Okay, good evening, dear colleagues, dear friends, dear participants. First of all, I thank Sripadi Institute of Management and Technology for inviting to this session. So my topic is from everyday problems to smart innovations. I think all of you, I don't know whether participants are faculties or students. Can you let me know?
Yeah, most of them are faculty, sir.
Okay. So, okay, that's good. So it should be an interactive session completely. I will not teach you, or I will not make a lecture completely teaching anything. But I want to be this session a very interactive session, so you can ask any question, doubts. So in this way, we can move, we can forward. Okay, let's start now. So my screen, everything visible, I guess. So
Yeah, it is visible.
okay, actually, we are science students. So actually, what is science? What is the science? Actually, anyone can reply. What is the science? Please tell me. Please just let me know. Anyone? What is the science? I'm checking whether you are alive or not there. No need to ask it ChatGPT. You can just whatever answer coming in your mind that you can tell. Yeah, Umana, is it audible?
Yes, it is audible.
Yeah.
Sir, science is the study of the world around us.
Yeah, correct. That means observing our nature, then asking problems, finding problems, and the first of all thing is the observing our nature with curiosity, making problems, asking problems, and finding solution to the particular problem. That is actually the science. So we should we have first of all the first thing is we have to observe our nature. Then we will see lots of problems, lots of issues in around us. Then the next stage is we have to solve the issue. So as a science students, we should ask many questions like what is this one, why this happened. Similarly, this kind of questions we should ask. Then then finding, then making solution, trying to solve that issue. That is actually in my topic is also from everyday problem to smart innovation. So we should find lots of problems surrounding us, many problems from our real time life, and how we can convert, how we can solve that problems into a smart innovation. That is my topic. Actually, that's why I'm asked this question. So Can you tell any problem around us? Some one or two problems can you identify from our real life? Any problem? It can be technical or non-technical.
Maybe electronic waste disposal.
Yeah, electronic waste disposal is a kind of waste because lots of CPUs, lots of monitors, we are dumping. So it can be a pollution to our earth. Okay, that's it. It's a problem. How Mark sir, what solution we can or any recycling method or how we can defend to this issue? This is our second. So first we identified the problem, and second,
Actually,
sir?
I haven't thought about this very deeply, but maybe we can start some facilities by government for electronic waste collection and all. And another option is to recycle.
Yes, recycling is one of the opportunity in front of us. Recycling, reuse and recycling is there. Reuse means one thing already used one specimen. We are reusing for the same purpose. Recycling means we are using the item for reusing the item for another purpose. Suppose, okay, that we are going to come into our topic. Okay. Why my slide is not okay. Here I saw you can see visibly one figure is there. That is one. You see this figure. That means rubbing balloon over hair. This is a one natural phenomena that we all are experiencing in our real life. For our childhood life onwards, we are experiencing this one. While rubbing balloon over hair, the hair will be attracted to this balloon. It's a natural phenomenon.
Can everyone hear? I cannot hear.
Yes, it is audible for us. Maybe, madam, can you leave and rejoin? Try that. It is audible for everyone else.
This my side is fine. Okay.
I'll rejoin, I think.
Okay. Why this happening? This attraction between hair and balloon. I already told this session should be interactive. That's why I'm asking. If you have any issue, I can proceed as a lecture, no matter. But if it is interactive, to be better for understanding. So why this attraction happening? It's a kind of observation. As a science student, we are observing from nature this kind of phenomena. Or while rubbing a comb, after rubbing a comb over hair, then if you are placing this comb near to some paper pieces, the paper pieces will be attracted. Similarly, another phenomena, lightning happening in our sky. Why this lightning happening? So lots of things are there in front of us, surrounding us. So here I'm focusing one particular topic. That's why I selected this one as an example. So as seen in the figure, why hair attracting to the balloon after rubbing each other? Anyone can tell?
Dear participants, if everybody interact with the resource person, it will be more interesting.
It's a You know, anyone answering or not? If you don't know, you can tell. We don't know.
Sir, it is no. I think nobody is answering. You can continue, sir.
Okay. This actually happening. So for getting attraction between two materials, the first of all, there should be different charges between them. If one material is negative, other material is positive, then only they both of them will attract each other. Suppose both have positive charges or both have negative charges, they will not attract each other. So for attraction between any material, one material should be positively charged, other material should be negatively charged. That is the basic understanding. So here, while rubbing a hair over balloon, as it is attracting each other, we can tell that hair have some charges, either positive or negative, and balloon have positive or negative charge. So if hair is positive, balloon should be negative. Then only these should be attracted each other. So earlier, these materials doesn't have any kind of charges. Earlier, initially they are absolutely neutral materials, not charges at all. So after rubbing, only this happened. So suppose if we are experiencing the same phenomena without rubbing, if we are keeping our balloon over hair, there will not be any kind of attraction between them. After rubbing, only this will happen. So that the friction between these two materials causes generation of charges between them, causing generation of opposite charges between the hair and balloon. So actually, the hair becomes getting hair getting positive charges, surface charges, and balloon getting negative charges. So this attraction between this positive and negative charges getting this phenomena to attract hairs to the surface of the balloon. That is the uh, the basic understanding. Then we can ask many questions: why hair go to positive charge? Why balloon go to negative charge? Why it is not reversible? So it's I already told it's a natural phenomenon. Natural phenomena. All the material have properties either to attract or either to lose electrons from the surface. So hair have natural tendency to lose electrons. Similarly, balloon have tendency to accept electron. So with any material losing electron from its surfaces becomes positively charged, and any material accepting electrons to its surface becomes negatively charged. So this generation of positive and negative charges is happened due to the friction between these two materials. So similar physics happening between this paper and comb, similar physics happening while happening the lightning also. Here you can see in this video why lightning happening. Actually, in the snow, there are initially different stages of water molecules inside a snow. That is in terms of ice crystals, in terms of graupels, in terms of water droplets. So a big snow, it can around 10 to 12 kilometer height. So and internally there will be a higher flow of air through this snow. So due to this higher airflow, there will be a interaction. Will be a fast movement between the graupels and ice crystals, and finally, through the friction between ice crystals and graupels, as seen in this hair and balloon, there will be generation of positive and negative charges between them, and these negative crystals will be ice crystals will be sedimented down to the snow, and these graupels on top side. So there will be a positive side and negative side, separation of positive and negative charges, as already we saw in the case of hair and balloon. So a material having positive side and negative side is similar to a kind of battery, that is potential, if potential is there. So similarly, in our case, while rubbing balloon over hair, I already told there is happening a separation of a positive and negative charges. So actually separation of positive and negative charge is called as the potential. It is the potential. Potential, when there is a difference in the potential, that is called as the voltage. Wherever voltage is there, there is a tendency to generate current also. If we are making a path to pass the current. So here you see the separation of a positive and negative charge. If they are standing without changing its position, suppose it have 10 positive charges and 10 negative charges. If these charges are constantly alive, like 10 charges each other without changing that number of charges, then what happens? There is no potential, there is no difference in the potential. Without difference in the potential, it is not we can't consider it as a voltage. So potential should be considered as a voltage only if there is a difference in these potentials. So these differences can happen by the movement, the interactive movement, relative movement between these two materials. So if the balloon or hair moving each other, so the number of positive and negative charges can vary. So if the negative and positive number of ions changing means potential is changing, that is potential difference happening. If potential difference happening means there is the voltage generated. So this voltage we can convert into in terms of current. So it is a real-time example, like suppose we have two water tanks. Suppose both the water tank have same kind of water levels. Both have potential, but not difference. How? If the water level is same, means there is no difference in the potential. So there will not be a kind of water flow in between these two. So whenever one water tank have water level is higher and in the second water level is lower, then if we are connecting a small tube between these two tanks, then water flow will occur. That means potential difference is there. So if we are connecting these two water tanks with a small tube, water flow can occur between these two. So here the flow of water we can consider as a current. This potential difference. So this we can relate to our balloon hair example. So if we are attaching electrode, suppose if you are attaching electrode to this hair and similarly electrode to this balloon, and if you are taking wire outside and connecting one bulb, if they are rubbing each other, current will be generated through the electrode and we can see the LED is glowing. So in this method, we can generate electricity. That electricity we can store in a capacitor storage devices like capacitors, supercapacitors, and this energy stored in the capacitor further we can utilize for powering some gadgets like smart watches, some electronic equipments, and either or else we can consider this electricity as a sensing data. Here in the video you can see before coming to this one, the physics, what I already explained, with this friction between two materials generating electricity is called as triboelectric nanogenerators. This kind of electricity generators are called as triboelectric nanogenerators, and this effect is called as triboelectric effect. Tribo means friction. So friction between two materials generating electricity. So one material should be positively charged, another material should be negatively charged. So it is an affinity of the material. One material should have tendency to lose electron, and another opposite material should have the tendency to accept electron. If we are using two materials, both have tendency to lose electron. Suppose this kind of material we are using, so we can't generate electricity from the friction between these two materials. So this kind of effect is called as the triboelectric effect, where tribo is called as the friction. So in this video, you can understand the physics clearly, how electricity is generated. You see, here the pink color and blue color, these are two materials. One have the blue color have negative, it is a negative material, that is, it has tendency to accept electron like a balloon. And this pink color is positive material, that is, it has tendency to lose electron. So both have different affinities. So in this manner, we are tending to contact and separate these materials. It's a kind of friction mechanism. So by attaching electrodes, we can generate electricity. That's what I'm going to tell. So initially, these two materials are neutral, not charges at all. Then what happens if, while these two materials getting touch each other through friction, as we observed in the air and balloon, similar kind of positive and negative charges will be generated on the surface of the materials. Actually, these positive and negative charges are static charges. So this is a part of static electricity. So positive, it's a surface phenomenon. These charges are not like the charges present in aluminum or copper. Aluminum and copper is a pure conductors. The ions present is a moving kind of ions. But here the static electricity means these plus and minus are static ions. That means wherever it is generated, it will be generated only where friction happened, and wherever it is generated, it will exist in that place only. It can't move from one side to another side. So that is the name static. So similarly, anyhow, through friction, we achieved the positive and negative charges on the materials. That means potential happened. Then while these materials are separating, there will be changes in the number of plus and minus ions. That means potential difference happens. And through another mechanism, electrostatic induction occurring on the electrodes, we see while separation, what happens. You see, while separating these two materials, electrostatic induction happened on the attached electrodes. Here you see this yellow color is the electrodes attached to the materials. So the electrode attached to the negative material becomes inducing positive charges. Similarly, the electrode attached to the positive material getting negative ions, opposite charges. That is induction, electrostatic induction. This is also a natural phenomena. Suppose I have one highly negative charged material. If I am bringing another neutral material near to this highly charged negative material, the neutral material will induce positive charges on its surface. That is opposite to the highly negative material. That is induction. Opposite charge will induce. So by the combined action of contact electrification and electrostatic induction, current flow will happen through the electrodes. So in this way, we can generate electricity. You see, while moving this one, it is generating a positive peak, and while moving in reverse side, it is generating the negative cycle of the voltage or current cycle. So by the continuous contact and separation between these two materials, electricity can be generated. So how we can utilize this physics for our real time problems? We started by asking our real time problems. Umanath sir already told we have lots of electrical waste. Similarly, I will show you some examples what I did based on this physics, basic and fundamental physics. Before going, I already told this is a triboelectric effect. This effect was invented. Actually, it's an ancient concept. Static electricity is an ancient concept, but the possibility of generating electricity from this static electricity was invented by Professor Zhongling Wan in 2012 as a triboelectric nanogenerator. He was the same inventor who invented the piezoelectric nanogenerator, pyroelectric nanogenerator. Anyhow, it was an extension of a Maxwell equation. So the friction can be in different modes. As I told, as I show in the video, it can be a contact separation, just touching, separating, or it can be a simple sliding one material over another material. So based on that, how we are generating friction. So based on that, we can categorize the mechanism also, like contact separation, lateral sliding, singular towed, freestanding. So similarly, I told naturally all the material have some tendency either to lose or either to accept electrons. Already scientists made some list of materials which based on their tendency. This list of material is called as triboelectric series. We can see acetate, glass, human hair have tendency, aluminum, paper have positive tendency. Similarly, some polymers like polyethylene, polyacrylics, rubber have negative tendency. So for generating electricity based on this mechanism, we need at least two materials. Two material having different charge affinities. That is one compulsory part. That means one material should have high potency to lose electron, and the opposite material should have negative affinity to accept the electron. So if we are selecting two materials with different charge affinities, and by attaching electrons over the material, then making friction between these two materials, electricity can be generated. So the physics and mechanism is very interesting. So I already told this is a generation mechanism. You don't think we can replace our wind energy, we can replace our solar energy. You don't think like that, because currently it is the growing research field. It is not stabilized yet. I already told this. This was started from 2012 onwards only. So this is the current the research is going. More researchers are happening in this field, and in the nearby future, it will be stabilized. So the products based on this physics will be available in the nearby future. Currently, no products are available based on this physics in the market. So the current studies could able to generate maximum of milliwatt or microwatt range of power zone. We can't power our laptop or big gadgets with this, but some gadgets, low scale gadgets, we can run. Similarly, I told you different mechanical movement is actually it is a mechanical to electricity conversion mechanism. So so any kind of mechanical movements like wind energy, vibration, blue energy. Blue energy means from ocean wave. So biomechanical energy from our walking, normal walking, move, jumping, this kind of biomechanical energy. If we are from the vibration, we can generate electricity. That electricity we can utilize for our gadgets to replace our conventional batteries. So our aim is to replace the battery kind of storage, because battery making lots of pollution to the environment. We have to replace the battery. Suppose if we are making some suppose we have some sensors in our remote area, the replacement of battery in that sensors is getting very difficult. So suppose if we are making any devices based on this some kind of it is generated by that the mechanism itself can power running the sensor. In that sense, we can avoid the use of batteries. So this is a growing field. So already told, I am going to tell you some examples what I did based on this physics. So we have lots of wastes are there. One of the waste is was you see, we can see them during COVID time. Everyone used the mask, face mask, and gloves. Similarly, PPE kit. So it was a kind of noisy pollution to the environment during COVID time. So during COVID time, I did one work. While seeing this kind of accumulated mask, glove wastes in our surrounding, I thought how we can recycle or how we can recycle these mask, glove materials for generating electricity. From that thought, I recycled mask, face mask, and hand gloves for generating electricity based on the mechanism that I already explained. And I fabricated one sensor and one energy harvester and an IoT and a touch sensor for IoT application during the COVID time. This work was also patented. I will tell you in detail that. I already told this waste, the mask waste dumped areas. So we already know that time lots of COVID patients or any kind of disease affected person can be used this kind of mask glove. So initially, as a research students, we can directly take the material to our lab. So we need some safety measures. We have to do some safety measures. So initially we have cleaned, we have sterilized, we have disinfected, we have removed all kind of viruses, bacteria using some tests. So disinfection sterilization process. And we confirmed that we have removed all kind of bacteria, viruses, microbes from the waste. And after that, we have utilized these face masks and hand gloves for making a triboelectric nanogenerator. So we know the face masks have different layers, 3 layers. A standard face mask has 3 layers. It has an outer layer, hydrophobic, which repels the water droplets, and it has an middle layer, and also an inner hydrophilic layer. Hydrophilic means it can absorb water droplets from our exhaust, breath exhaust. So initially I tested what material these are. So separate layers, inner, middle layer, we have performed different characterization. For analyzing the material, the first we are using X-ray diffraction spectroscopy analysis. So for inner layer, middle layer, and outer layer, we from the XRD graph, we from this obtained peaks, we can analyze the material by comparing, by giving these peak values to the JCPDS file. One JCPDS standard library is there. So if you are giving these peak values to the JCPDS, it will tell what kind of material it is. So by analyzing these peaks, I analyzed that this face mask is made of polypropylene material. All the 3 layers are made of polypropylene materials. But the fabrication process, that electrospinning or melt, that fabrication process is different. That's why these figure C, D, E shows the microscopic visual of the all the 3 layers. So why these are different means the fabrication process was different for the 3 layers. Anyhow, the 3 layer is a polypropylene material that I can confirm. Similarly, the polypropylene material has highly triboelectrically negative affinity. It have tendency to accept electrons.
Excuse me, sir. Excuse me, sir. So it seems that these materials are crystalline materials because XRD pattern shows like this. Is it like that? Crystalline?
Yes, sir. It's a kind of some crystalline tendency it has. That's why its peaks are showing.
Because the XRD pattern shows that it is crystalline. Amorphous is not like that, no? XRD pattern.
Yes, sir. Yes, sir. Yes, sir. It's a crystalline material.
Okay. So what are these actually elements are there? Actually, what are the elements? Did you identify the elements?
Which elements?
In that
Bond neutral.
Yeah. In that XRD pattern, it shows peaks.
Actually,
peaks are coming
actually,
from
actually, it's available for the XRD peaks for the pristine polypropylene material. It's already available. So I compared actually the peak, whatever peak obtained from my face mask, I compared with this polypropylene, which is obtained from from the literature. So these XRD peaks were matching with that. So from that, I identified this is the polypropylene material.
Okay.
And after that, I have performed some characterization method like Kelvin probe microscopy, LCR meter, zeta potential analysis that I didn't included here. With that, we can analyze whether this material have triboelectrically positive affinity or negative affinity. I already told all the material have different ranges of positive affinity of negative affinity. That intensity can vary, but I have to analyze whether this polypropylene material have triboelectrically positive affinity or negative affinity. For that, we have performed Kelvin probe microscopy analysis for understanding the surface charges. So from that analysis, I confirmed that this material, this polypropylene material has triboelectric negative affinity. So one material I fixed here. Similarly, the another waste we have seen during the COVID time was the gloves. Different gloves were there: nitrile gloves, latex gloves, vinyl gloves. These are different chemical combinations. So here I for final device fabrication I use the nitrile glove only because it compared to other gloves it has higher positive affinity. Because this nitrile glove is made up of nitrile, a kind of nitrile butadiene rubber material. This is a rubber kind of material, and vinyl is some polyvinyl chloride material. So the material also differing. So this nitrile glove has more triboelectric positive affinity. That also I confirmed using Kelvin probe microscopic analysis. So we got 2 materials. I already told for fabricating a triboelectric nanogenerator, we need 2 materials. One should be highly triboelectrically negative affinity material, and other material should have triboelectrical positive affinity. So then my aim is to make a device and attaching electrode on the materials and making friction between them, collecting the current. For that, I fabricated one 3D printed structure like this. So with the help of a spring in between, it has a top separable top and bottom parts. supported by a spring. So we can press and release each other. This is the release stage and this is the press stage. So one side I have attached a 3-layer mask, our face mask, attached with a copper electrode. One small piece of face mask I have taken, and below that just attached a copper electrode and kept on one side, upper part. Similarly, in the opposite side, I have attached a glove piece along with the bottom aluminum electrode. Then made arrangement like this. So by simple pressing electricity generator, I will show you some videos here. Before that I have to turn. Okay, so by fixing the arrangement like this, I already show you video how voltage, how current generating through the mechanism. By the friction between this face mask and glove, we could able to generate a minimum of 50.7 volt and 4.8 microampere current. So this first graph here we can see the voltage and current graph. Actually, this is I already told I have we already experienced different kind of glove material. I tested different combination. That means face mask with nitrile glove, face mask with latex glove, face mask with vinyl glove, and just experienced how much voltage and current is generating. So nitrile glove with face mask combination, we got 50.7 and 4.8 microampere current. Similarly, latex glove with the face mask, it was less compared to the first one. It was just a 20.1 volt by 1.6 microampere current. But we couldn't experience much voltage and current from this vinyl glove with face mask pair. So based on this experiment also, I could able to confirm this is the best pair, nitrile glove with a face mask. And we already know the face mask has three layers: inner layer, middle layer, top layer. So with different layers, single layer, and combining 2 layers, and combining 3 layers, I have tested the voltage and current for different combination. Nitrile with the different layers of face mask, latex glove with the different layers of. Even though latex performance is less, I just tested with the different layers of the mask. Finally, I got the maximum response of 50.7 volt from the combination with all the 3 layers, where top layer touching with nitrile glove. So here we can see the voltage and current graphs also. And this experiment we can visualize using console simulations also. We not need the experimental studies. With the simulation studies also, we can by giving the material properties, the simulation software, we can identify by touching with the different forces, different material dimensions. We can analyze how much voltage and current can be generated from this mechanism. That also we can do. Anyhow, then different analysis we performed for because it's an energy harvesting device. We have to find how much power it is generating. Yes, sir.
ठीक है बस वाला हबो
You're asking me, sir.
Oh, sorry.
Okay. So different analysis, I calculated the power generated by this device. We could able to generate 57.5 microwatt power, because as it is a power generated device, that's why I calculated the power from instantaneous voltage and current analysis. I could able to charge the capacitor. This kind of in detail I'm not going to tell. So by simply connecting the tribolytic mechanism actually generating alternating current and voltage. The voltage current will be in the sinusoidal format. So for powering some gadgets, we need to convert this AC into DC. So we have rectified the alternating signal to the direct by using some rectifier combination, bridge rectifier combination we have used. And then the capacitor, the energy was stored in the capacitor, and the stored energy we utilize it for powering some gadgets like small watches and LEDs. That video I can show you by simple pressing. Initially, we have used one bridge rectifier capacitor combination. So the voltage across capacitor will be initially it is charging and it will get stabilized. So after getting the required energy in the capacitor, our gadget will power. So that is what you visualized in this video. And also one more thing I did here, instead of considering the device as an energy harvester, I considered it as a sensing data. So as a pattern sensor for dispensing a smart sanitation dispenser I fabricated, because this work was done during the COVID time. So that time we need sanitation dispenser. So by pressing this device connected to a microcontroller, so that the electricity generated by our device will trigger the microcontroller to release, to open and close a solenoid valve attached with the sanitizer dispenser. So by pressing it, the sanitizer will dispense some amount of sanitizer. So similarly, this is an IoT enabled microcontroller device. So all the data, how much voltage generated from the device, how much current generating, how many persons using this device per day, and what is the amount of sanitizer inside this our sanitizer dispenser. This kind of data I have uploaded in a cloud, so that everything we could able to monitor real time through our mobile phone or laptop. So that kind of analysis we have performed here. You can see just by pressing, it's just a sample prototype only we have fabricated in our lab, just by pressing the sanitizer dispensing. And this is the IoT cloud visualization through our mobile phone, voltage and sanitizer volume. Similarly, after suppose sanitizer amount level is low, less than some particular threshold value, a message will be passed through the authorized person to refill the sanitizer dispenser. So it is a simple one, just combined face mask and glove. Both are collected from waste sources. Just attached electrodes on both the materials and made a structure for making the contact and separation easy, or for making friction between the materials. We could successfully able to generate electricity. That electricity we utilize it for powering gadgets, and that electricity we use it for considered as a sensor for making an IoT device. So this work already patent granted. So from simple observation, how we can what we can do with this much amount of waste from our surrounding. From that simple question, we could able to solve one issue. I'm not guaranteeing with this invention we can't avoid all the pollutions from mask glove kind, but some innovation we are. One more work only I will explain here. Then because I don't want to bore you much. For understanding the basic physics only, I'm telling this one more I will give you. So similarly, as similar to face mask and glove, another waste we are facing, it is a Pampers, a baby diaper. Lots of the families are facing these issues. They're having kid. How many number of diapers are disposed from a single home itself? What they are doing, they can't do anything. They're dumping into just a waste. So the dumping of baby diapers is an issue. This issue, actually, I realized it. I faced this issue, dude, when I have a kid. I thought what to do with these diapers. From that question, I fabricated one tribolotic nanogenerator for making a mini weather station. I will tell you. So I'm not going to tell you about the impact of the diaper waste. You see, here in this work, I collected the gel. That is the urine absorbing gel. We know inside the diaper there are some water absorbing, super absorbing polymer gels are there inside. These gels can 1 gram of the gel can store at least 400 ml of urine or water. That much absorbance it has. So it's a kind of sodium polyacrylate crystal materials. So the urine absorbing inside this gel, it's a kind of osmosis process. So by applying reverse osmosis, we can remove whatever absorbed inside. So a reverse osmosis method, I removed the urine from the diaper powder, and that diaper gels were converted into its natural super absorbing polymer powders and considered as a tribolotic positive material because sodium polyacrylate powder has tribolotically positive affinity. Here also I need two materials. One positive material having with the positive affinity, one material with the negative affinity. Here the super absorbing polymer gels extracted from the waste diapers, that powder I considered as tribolotically positive material. And similarly, the butter sheet, you know, it's a someone tell it's as a cooking sheet or a baking sheet for protecting our food from adhering to the vessels. It's a actually a PTFE, polytetrafluoroethylene coated simply Teflon coated cloth material. So this Teflon is there in the surface of this sheet. This Teflon is a tribolotically negative material. So in this experiment, I compared this tribolotically negative Teflon material, that is this baking sheet, with the positive powder collected from these waste diapers. So I already told, these are the structure of the diapers. We see different layers are there. In between layer 3 and layer 4, there are super absorbing polymer powders. These are the reason for the absorption of the urine. So it's a sodium polyacrylate material. Different methods actually I followed initially. And finally, for converting this gel into powder, through reverse osmosis process, I did a natural drying process. Just after collecting all the gels, initially we have removed all the urine from the gels, and then all the collected gels were exposed to environment for 7 days. So gradually, through reverse osmosis, the water content inside these gels were evaporated and it dried to its powder shape. So in this way, we got the super sodium polyacrylate powder. This powder we utilize. So initially I told these are collected from waste. Initially we have performed all the security tests like sterilization. We have okay, after collecting diapers, we have removed urine, then converted into powder. Then similarly, baking sheet also cleaned with soap water, sterilization done. And finally, we made one structure, 3D printed structure like this. One cylindrical structure with with two half cylindrical structures. And on half cylinder parts, we have attached this baking sheet with bottom aluminum electrode. Bottom to this sheet, there is an aluminum electrode. And similarly, both sides we have attached. And inside this cylinder, we have filled the powder extracted from the waste diapers. Then by simple shaking, we could able to generate electricity. You can see in this video here, by simple shaking, I have connected one capacitor across these electrodes. So the capacitor is charged. Around 5 volt we got across the capacitor. That was really interesting. So actually, how this mechanism works? This is a kind of I already told in the initial slide, like different mechanism is there. Like either it can be a contact separation, it can slide over. So this freestanding mechanism I tried here. That means based on that it is working. That means this pink color is that PTFE material, and this green color is our triboletically positive powder. By simple shaking, this positive material contact on both sides, making friction between them, getting positive and negative charges. And through electrostatic induction, electron opposite charges will be induced on the attached electrodes, and electricity generated across the loop. This is the mechanism that I. So similarly, here also we got a sinusoidal current and voltage waveform. Here also we have confirmed. You can ask why I selected this material. How you confirmed the triboletic positive affinity or triboletic negative affinity of the two materials. For that, we have performed different kind of analysis, as I already explained in the first try, like Fourier transform, infrared spectroscopy, XRD analysis, then energy dispersive spectroscopy, Kelvin probe. Lots of characterizations we performed to understand this powder. The diaper powder has triboletically positive affinity, and this baking sheet has triboletically negative affinity. So by simple shaking, we could able to generate electricity from this mechanism. So we have detailed analysis. We have shaken the cylinder with a different axis and analyzed how much voltage current is generating. It is based on the contact in which angle getting more area of contact. Based on that, the voltage and current is different, vary. And also a different area of baking sheet we have tested, and load analysis for finding the output power, how much power is generating from this device. We calculated it is 259.15 microwatt power generated across a load of 10⁵ ohm. And we tested charge in different capacitors ranging 0.1 microfarad up to 100 microfarad. We could able to generate a maximum of around 7 volt across 0.1 microfarad with 3 seconds of time. That was also very interesting. And finally, we have made one setup and connected a propeller on this our cylindrical shaped structure. So by simple wind, this propeller will rotate, our device will rotate. So through simple rotation, the both material will get friction and electricity will generate it. Similarly, I made a wind energy harvesting device. So the mechanical movement through the wind converted into electrical terms. And that electricity, similarly, as in the first work, that electricity is stored in the capacitor and powered gadgets. We can see in the second video. You see here in the second video, by simple rotation. By simple rotation, it is generating alternating current and voltage, and that is converted into DC by rectifying circuit and via powered gadgets, digital watch, without support of any kind of batteries. So it is a wind energy harvester. And finally, I have calibrated our device with a conventional wind anemometer device, sensor probe, hot tour anemometer. This is a device, perfect device for understanding how much wind flow is happening. So we have calibrated our device with this hot tour anemometer And finally, we found one equation between wind speed and voltage generated from our device. One equation we found, like y here you can see y is equal to 6.487x plus 0.66016. This equation obtained from the calibration method. That is, here y is the voltage generated from our device, and wind speed, x is the wind speed. Wind speed we have calibrated using the hot wire anemometer device. So this equation further we have programmed in the microcontroller, so that the microcontroller itself could able to convert the electricity generated by this device in terms of wind speed. So we have programmed this equation in the microcontroller. So we could able to understand the real-time wind speed in terms of meter per second. That data we have uploaded in cloud, and we could able to monitor through our laptop or mobile phone through internet support. So similarly, in this way, I could able to notice the wind speed. As in the first case, the electricity considered as a power source, we powered a normal gadgets like humidity, temperature monitoring device. It's a normal gadget without a battery. It's just powered with the support of our device. And in the combined action, we could monitor wind speed, humidity, temperature, and I named this as a mini weather station. You can see in this video that it is rotating. Initially, we didn't use any kind of battery inside this digital thermometer. Meanwhile, the capacitor is charging, rectifier circuit is used, and while connecting the terminal to the capacitor node, it is getting charged. So here it is showing the temperature and humidity. Same time, here you can see this is our computer screen, and this is our mobile phone screen. With the support of internet, we are getting the real-time meter per second wind speed values. We have calibrated this with we have compared the data with our hot wire anemometer data also, and we achieved 95% accuracy with this. So we didn't use any kind of battery here. So based the simple physics mechanism we utilized for making a weather station here. This is also a patented work. And similarly, we have done lots of works also, earthquake monitoring device, and other kind of devices also fabricated. So for understanding the physics, I think these two examples is fine. And no, this is your time. So with if you have curiosity, problem solving ability, utilize our creativity to understand, to observe our surrounding, find some problems. Researchers, we can consider our problem as a problem or problem as an opportunity. Whoever visualizing a problem as an opportunity, that kind of personality have a research skill. As a research person, he need always he should think how to convert the problem. He should consider the problems as an opportunity to find an innovation from that problem. So this here actually for making this kind of devices, we not need any kind of big labs. From our home setup, from our normal setups, we can make this kind of devices. It's a basic. So instead of collecting the material from waste also, we can synthesize our own materials in our lab. Having tendency to high positivity or negative, currently no, I have worked that kind of, I have fabricated that kind of materials also. Without collecting material from waste, I fabricated different kind of materials, films, thin films, flexible, stretchable kind of thin films, having different affinities, combined these with different structures and fabricated lots of devices. That part I'm not going to explain here because for understanding physics, this is enough. So similarly, this kind of hands-on learning we can experience and we can ignite our scientific journey. So we have to observe some things. I'm giving to you that we have to observe our daily life with curiosity. Try simple experiments. Never stop asking why. Always we should ask questions. Then only we can have curiosity to answer or find the solution for that. Join some science fair experiments. Do some DIY projects. So we need passion, scientific passion here, not pressure. We have to follow our interests. So we have to do small research projects. We should read scientific articles for understanding much. We have to participate in exhibitions. And we have lots of sources are there. Online teaching sources are there. Local communities, competitions we can participate. We can find some mentors or supervisors from different areas. Through world it is available also. So, and from research, endless career paths are also there. We can start our innovation. IITs here, IIT Madras supporting startup for starting a startup companies here. Similarly, all the institutions have the tendency like that. So based on this physics, at least we can make some products. We can solve some real-time problem for a normal person. That kind of products we can develop. That kind of startup we can do. We can grow. So that is the ultimate aim of a research. So I'm telling we not need any kind of big lab to become a scientist. We need a curiosity. So this curiosity is our superpower. India need our brain. So you start your journey today itself. That's I concluding here my topic here. If you have any queries, you can ask.
Yeah, Dr. Basith, can you hear me? Yeah, actually,
Yes.
it is a very good presentation from your side. Actually, I
I
am
didn't
really.
tell any kind of big science. I didn't mention it
Yeah,
here.
that is okay. But
Very
from
basic.
simple innovation, very basic things, and you have done a very good job. So, can you go back to slide number 13?
13.
13. I think it is 13.
Yeah, this one.
13. No, not this one. I think some that pressure device. Okay, this will be good. This will be good. Okay, so have you identified what is the minimum or maximum pressure? Is there any relation that with the current generation with pressure? Have you find out? Suppose if you increase the pressure or frequency of that pressing.
Yes, sir. Yes, sir. Actually, we have analyzed it with the different frequencies. You can see in this example, you can see different frequencies we have tested. Okay. You see, this one with the 2 hertz movement, 4 hertz movement, 6 hertz movement. And different applied forces also we have done, like 2 Newton, 1 Newton, 2 Newton, 3 Newton. So we actually, it's a detailed project. This work already published because so different Newton forces, different frequencies, different speed, we have tested all the characterization.
Okay. So what is your result actually? It is not clear from the slide. If you increase the frequency, okay, current may be increased. if you increase the pressure, what will be your result?
Both are parameters, sir. If you increase frequency also, initially the response will increase. It has an there is a threshold frequencies there. So after reaching threshold frequency, maximum frequency, after that it will response are reducing.
Okay.
And force, depending on force also, as force increasing, response going increasing.
Yes. Yeah. So next question is, did you use AI, artificial intelligence, while design or identifying the materials? Because this
artificial intelligence,
yeah,
artificial intelligence is not used here, sir, for identifying this kind of materials.
Yeah.
No. Because currently the research trend is going in this field, tribolotic nanogenerator. The research is trending with the AI and machine learning, because this sensing data, the device generate electricity can consider as sensing data. That sensing data given to artificial neural networks and making combined complex structures. That's happening currently in this research.
Okay. So you use two electrodes. On one side, I think, if I remember correctly, one side it is copper and other side it is aluminum. Am I correct?
Yes.
Why two different types of material you use on the both sides?
Actually, some electrodes also has some positive and negative affinities, sir. You see, here is the aluminum. This is a tribolotic series. Aluminum, usually the most of the materials having the surface charge phenomena are dielectric materials or insulating materials. So some conducting materials also have some surface charge phenomena, including aluminum, copper. Here, actually, I didn't mention the copper here, but copper and aluminum also has some positive and negative affinity. So aluminum compared to copper, aluminum is there in the positive side.
Okay.
So for supporting positive material, I used aluminum with positive material. For supporting negative material, I used copper, because tribolotic affinity of both aluminum and copper also matters.
Right.
We are. This was my earlier work, because currently we have fabricate. I'm working in piezoelectric nanogenerator and magnetoelectric. The current research is running with magnetoelectric materials. So for coating electrode also, we can utilize different equipments like sputtering machines for making product kind of final devices. But for house, we can, for a simple scientific test, we can attach some electrode like aluminum foils, normal aluminum foils that we are purchasing from local markets. That itself we can utilize as a electrode material.
Okay. Thank you very much.
Yes. Any other queries?
Presentation was very insightful. Can you hear me?
Yes, here. Any doubt, ma'am?
Yeah. Can you please say more microplastic? Can we do something solution for microplastics? Because
of course,
compost also contains microplastics nowadays.
Yes.
Improper segregation of wet and dry waste. The plastics with the food materials go into the bin. So when they convert the food materials into compost, the microplastics will go into the soil.
Yes. Understood. Of course, it's a good question, a good observation. I appreciate you, ma'am.
How to
Actually,
find out the amount of microplastic in compost? This
okay.
one.
Fertilizer.
Exactly, I don't know. But here you subjective kind of materials are already a kind of plastics like polyester, polyethylene, polypropylene, PVC. These are plastic kind of materials. So I think if you are focusing microplastic, that microplastic can be either of any of this. It will come under any of this plastic category. Either it will be PVC, polypropylene, polyethylene. If you are anyhow, if you are able to collect microplastics and make a thin film or a structure, that film itself we can consider as a triballically negative material. But I don't know how to quantification. We have lots of characterization methods usually while making nanoparticles in our lab. How many nanoparticles are there in a particular 1 ml of solution? This kind of testing we are using UV visible spectroscopy. UV visible spectroscopy. You understood, ma'am? Yeah, that is UV visible spectroscopy is there. So all the material has its own based on concentration, the lambda can vary. Wavelength. All the material have its own absorption and that diffraction wavelengths are there. So it is a kind of as see in our fingerprint. Everyone's fingerprint is varying. So similarly, all the material has its own absorption and diffraction wavelengths. Based on that, using by doing Raman spectroscopy, UV visible spectroscopy, or NMR, lots of spectroscopies are there. These all are for identifying the amount of the material inside. So you can, if you have some composite, you told 1 ml of composite or 1 gram of composite, you can do visible spectroscopy or Raman visible spectroscopy by identifying the lambda. Based on that, some calculation you can find the concentration per ml or mg.
Okay. Thank you, sir.
Nearly some researchers I noticed that microplastics are there in everywhere in the food, even well water, even breast milk also have this kind of things. So it's a research opportunity is there.
Thank you, sir. Thank you so much. Can we get your contact number?
Yeah, my contact number is there in the slide. 9497 302 369. Actually, through my presentation, I intended to show you anyone can start research. It's not doesn't need any kind of big lab. It doesn't need any kind of degrees. Whoever have a curiosity to observe our problems, to find solution, that curiosity we need. That's only I intended with this presentation. Okay, any other? These are just basic. Okay, basic devices only I explained. Actually, if you are checking the literature survey, latest research, you can see the big range of applications based on this physics itself.
Thank you, Dr. Said. I think if there is any more doubt, you can ask. Otherwise, we can conclude this session. Anyway, if you have any more doubt, no, you can see the email ID and phone number in the slide, or you can contact me for the contact details. I will share you. You can contact him personally. For further, if you need any help or clarification, you can contact him. So, with that, I would like to thank
Can we
Dr.
get the slide, sir? Or a video? Can we get the video of this?
Yeah, I have recorded the video. I'll share the recorded video later. After all the sessions are over, I will share
Okay.
the Google Drive. Yeah.
Okay. Okay.
Okay.
Thank you, sir.
Okay. So, on behalf of Sripati Institute of Management and Technology, I would like to thank Dr. Said for delivering the session. Of course, it was an interesting session, and I'm sure everyone has gained some knowledge which will be useful in their future. So, once again, on behalf of CMAT, I would like to thank Dr. Said, and that's all for today. Our next session, tomorrow we will have our next session, morning at 10 a.m. So the session is handled by Dr. Manu S. Mohan, and it is based on characterization techniques like SEM, TEM, etc. If you are interested in learning those techniques or to know the physics, you can join tomorrow. And for now, I'll share the feedback form. And once again, I'd like to thank Dr. Said, and that's all. We can end the session right now. Thank you. Thank you, Said.
Yeah, thank you, sir. Thank you, everyone, for attending. Sorry for boring you. Okay, my leave.
Yeah, it was interesting, not boring. Thank you.
Okay, okay.